S-Chan presents educational video lectures. Difficult concepts made easy. Study anywhere, anytime.
Hello students, we have done in the previous videos about the operational amplifier, how they are used in the inverting and how they are used in non-inverting mode.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
Welcome to S-Chan Academy. My name is Kanhaiya Jha, and in this video we will learn about the other parameters of the operational amplifier, and the most important we learn here about how the operational amplifier can be calculated as a weighted summer. Summer as basically how we add the particular two inputs, sum up. So we can see that this is the operation amplifier basic design that we have discussed. So we can see that the leg number 1, leg number 2. In the 1 we can see we are having R1, R2 and R3 where we want to add entire thing, and accordingly we can calculate the particular output. So as it is summer, it is basically that how in the particular, the second one is a grounded, and we are adding this and we are calculating the particular input. So focusing more to this particular circuit, if the summer has to be designed, the circuit is very simple, that we can design the circuit like this. This is the particular input and this is the particular output. So we can say that 1, 2, we can ground this, and after that what we can do is that we can add it here. Whatever the number that we want, we can add in the particular input. Okay, and then as we can see, we can connect a connectivity between the input to the particular output. In a very layman language, you can see how the output is connected, how the input has been added with the more option. So we can see that it is a V1, V2, V3, and this is R1, R2, R3. So V1, V2, V3, and this resistance is R1, R2 and R3. So inverting mode, the second leg is grounded and the first leg is generally calculated to the particular inverting particular mode. So this is how the connection is generally analyzed. With this we can see here. So whatever we are getting in the output now will be the sum up. This is the weighted summary. This is another weighted summary that we are using one particular op amp, we are connecting with another one, and then we can see that in the inputs there are number of legs here, in the input there are again output, and we are connecting to each other. So let's take an example, very easy example, that we have learned p-n junction diode, transistor, and then logic gates. And after doing a simple logic gate and or a NOT gate, whatever the gate that we study, that was all about that how the two particular logic gates were connected to each other, how we were connecting the two particular inputs, and when the two inputs were connected to each other, we were getting the combined output. Where the two inputs are connected to each other, then we get the combined particular output. So we have studied. So in here also we can see that we are using the two operation amplifier. The one is this and the one is this. We are using the particular connectivity here, and we are also using it here, and then we are connected it with one another. So we can see that V0 is equal to V1 RA by RI 1 RC by RB plus V2 RA by R2 RC by RB, and then minus V3 which is R0 by R3 minus V4 RC by R4. So this is the configuration that we study. This is the configuration we study, that how the variation is generally calculated in this particular weighted summary. So the output that we get here, let's start V1, we are using it here, which is RA by R1, this is the R1, this is RI. Then RC that we are using in the here output, so V2 will be RA by R2 plus R2 by RB, and this is RC by RB. So we can see that how we are making the calculation, how we are calculating it with the different particular signal, input and the output, and depending upon the input and the output, we generally make the particular calculation. So V1 is RA by RI, RC by RB, plus V2 RA by R2, RC by RB, minus V3 RC by R3, minus V4 RC by R4. So these are the calculations that we can do it. These are the calculation that we can do from the input to the output, and depending upon this particular calculation, the operational amplifier can be said as a summer, or that can be said as a adder also. Okay, here we can see the single op-amp difference amplifier. So this is again the two legs. We can calculate R1, then R2, and then R3, and then this is a linear amplifier amplification. And when we are calculating the propagation of the signal related with the superposition principle, what we generally know is that the total is the addition of the individual. That when we are using the different individual input, the total output is basically the sum of the individual. So this is in the linear, what we are getting in the input and what we are getting in the output. So again, coming to the circuit here, or coming to this particular circuit, we can easily see that how we are in the particular input, we are connecting the particular legs, and after connecting the particular legs, we are calculating the total calculation. Here again I am repeating, here we can see this is the operation amplifier, which is at the leg 1 and the leg 2, and we are getting the here as the output. So in the leg 1 we are saying that this is R1, R2, not only R3, we can connect it to the Rn, the nth particular value that we can calculate, and it will follow the same sequence. So here you can see that V0 is equal to minus of Rf by R1 V1 plus Rf by R2 into V2 till Rf by Rn into the Vn. So this is the particular value. This is the Rf that we are using the value. Then we are using the value 1, 2, and 3, and we can go to the any particular nth factor for the particular calculation. So here again repeating, taking. So we can see that this is the op-amp difference amplifier where we are making the calculation, and here we come to the concept here that how we are going to do this. So when we say summer, so summer amplifier is basically here we are using by connecting the particular inputs. So in the one particular leg of the input, we are connecting the different values of the input, and then we are calculating the collective output. The collective output that we can calculate, that the oscillating value that we can calculate. So in the operation amplifier, we can make changes with the particular input. In the one particular leg, we can add different values, and we can get the collective output. Collective output in the sense that whatever the output that were collective in this, what we generally say the add up output, that the total output, when we are using the individual values, then we can calculate a total particular value also, that what will be the total value in this, how we are calculating the total value and making the particular changes and all. So yes, in the operation amplifier, we really operate the input, we operate the different values of the input, and we rotate the different values of the input, and then we calculate the combined value of the input. So we'll get the combined value of the output also in this case, and then we'll make the particular calculation. So this is the particular thing. Here again I say that if you look at the previous circuit, in the previous circuit also we can see that how we were summing up the different particular R1, R2 and R3, and then we are making at a particular calculation. So we see here that how we are doing this. In earlier circuit also we have done this, that how we are using it a different op-amp. So either we so here it is a summer. So summer is generally, you can see that in the particular given output how it can be used as an addition, that how the value of the input is generally changed, and depending upon the change value of the input, we are making the particular calculation. So we have done this particular thing. So we have learned till yet in this video that how the operation amplifier is generally used as a adder, summer, how it is generally used when we are using the single op-amp or a multiple op-amp, how it is connected to the feedback. So now we'll take a small break, and after the break we'll proceed further and study more about the operation amplifier. Thank you.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Hello students, welcome back to our video. So before this we have learned that how we are using the operational amplifier as a adder, how we are using as a summer, that we are using the one particular gate and we are connecting the different inputs at a one particular gate and connect to the output, and how we were calculating the combined output. So now we'll proceed further. We'll discuss the amplifier as a difference amplifier. So till yet what we have done, that either we are connecting the one particular gate with a different input values, and then we are calculating the particular collective output value. How we are making the particular output as a grounded, and then we are making the calculation. So here we are using the op-amp as a difference amplifier. So one is use R1 and R2 and then R3, and then we are using this. This will be a linear circuit and will follow the particular superposition, that the totality will be the addition of the individual. Then we have this circuit where we can say V particular O is minus of R2 by R1 into VH. So this is the output that we will get. So here we can see this circuit. Now summing up and coming from the particular beginning, we have discussed operational amplifier as an adder. As a adder in the sense that how we generally have the different inputs and we combine the different inputs and we get the collective output. How in the particular leg of the input different values are connected together. And when the different values are connected together, we are getting the combined output. We have a variation with the input and the output. How we are looking at this particular circuit, we are using this op-amp, we are connecting to this particular output, and then we are getting a collective output from here. Here we can see that here again that V output is equal to V1 RA by R1, RA by R1, then RC by RB plus V2 RA by R2, the RC by RB minus of V3 RC by R3 minus V4 RC by R4. So here how we are connecting this particular videos together, circuits together to understand the particular output. So we study here. Again we can see in this particular figure also that how this is connected together. Here we can see the amplifier which is connected together. Again the difference in the amplifier which are connected together. So here we can see this. This is basically elaborated from here. Here also we can see how they are used as an adder. The weightage summer, that we are connecting one particular circuit, and from the circuit we are connecting the different values R1, R2 till Rn, and this is the RF. So again every particular value we not depend upon the RF by R1 into V1, then RF by R2 into V2, then RF by R3, and we will proceed till RF by Rn till the value of Vn. So here the collective output is generally calculated from this. In the second stage, as a adder, we can see that in spite of one op-amp, we can use the two particular op-amp and they can connect with each other. This is 1 and this is a 2, and we can calculate the particular output from here. So here also we can see how we make the variation in the input here and here, and then we can see in the output. Here we can see that in this input we R1 and R2 is connected, then here it is connected. This is R3, R4 and RB. This is RA, RB, and this is RC, which is connected to each other. So the output voltage V0 is equal to V1 RA by RI, RC by RB plus V2 RA by R2, then RC by RB, then minus of V3, RC by R3 minus of V4, RC by R4. So here again we can see that in the previous case, we are using the one particular operation amplifier, and in the particular leg we make the connectivity, and then we calculate total effect. In this, what we are doing is we are using the two operational amplifier, we are connecting them, and then we are calculating the total particular effect. So both the calculations we can see here, and we can see that this can be, the operational amplifier can be calculated as a summer in the sense that when it has ability to sum up the particular inputs and to calculate the collector individual output. Then we have calculated about the difference amplifier, that how the difference amplifier can be calculated and how we can using the simple of the superposition in this. Then operation amplifier application, we have discussed that in the difference amplifier that V naught is equal to minus of R2 by RF by V particular output. So all these things we have calculated. So the summary thing is that we can use an amplifier for different mode, inverting and non-inverting. When we say summing, the summing can be analyzed when there are two things when we can do in summing. Let's understand it one by one. First is this, that I have this particular op amp, and this is the one input, this is another input. Let it be 1, 2 and 3. So when I want to add it, then I can simply ground this, and then I make a connectivity with the different values here. Like this, and then we make a connectivity from here, input to the output. So we can see that this is R1, this is R2, this is R3. Similarly, it will be V1, V2 and V3. This is the RF value. So depending upon the RF by R1 into V1, RF by R2 into V1, RF by R3, we can move to the n particular numbers. And when we move to the n particular numbers, then we can calculate total particular value. Second thing is that how we are making this connectivity with another op amp that we are using. Here also we can make a connectivity here, and then we can use the different values in this. Again we can ground this, and then we can make a connectivity to the output. So from one particular value, as you can see in this particular figure, that this is the type, this is the another type that we have discussed. This is how one particular operation amplifier is connected to the other, and when it is connected to the other, one has a particular inputs and the other one has also the particular inputs. So depending upon the one value and the other value, we are making the calculation of this. So the total that we can calculate here is V naught is equal to V1 RA by R1, RC by RB plus V2 RA by R2, RC by RB minus V3, RC by R3 minus V4, RC by R4. So this is how this can be calculated. Either it can be used for the single op amp, or we can use it for the multiple op amp. Okay. So we can use this particular value. So adder in the sense that if we want to add the input, we can add the input and we can get the collective output. We don't have to use this separately. That is the reason it is operation amplifier. At any time we can operate the input or operate the output. So according to the operated input or the operated output, we can get the value of the input or the output. So this is the variation in the circuit that we can do. Either one single op amp is used or the multiple op amp is used. Then it can be used here as a difference sum and a difference amplifier. So this it will use as a single linear circuit, and from this particular single linear circuit it can be used. Here also we can see that R1, R2 and then R1 you can see is connected here, and according to this particular R2 and R4 value we can make the particular calculation. So again we can see here that application of superposition inverting is there, where V is equal to minus of R2 by R1. So this is R2 and this is R1. So this is the particular ratio that we generally calculate in this particular calculation. So we see here the different circuits that we can make, how the summer circuit is made, how this particular weighted summer is made, how we calculated the particular operational amplifier as a particular adder, differentiator and all. So we learn here that in the operational amplifier we can that in the operational amplifier we can change the input as we required. The simple example that I have given, that after learning the 3 gates and or a not, all the gates that we study is a combination only. So here also the operational amplifier can be used as a, which we can see that the adder or the summer. It means that if we give the different values of the input at a given time, we can get the connected output. Whatever the output that we get will be connected to each other, or we can connect the different op-amps together to calculate the one particular output. So both the addition can be done, either the addition can be done in the input mode, or the addition can be done at the various operational amplifier which can be connected to each other, and after the connectivity they can work together. So this amplifier is basically a very important particular module as far as exam is concerned, and as far as the industry is concerned is a very important particular integrated circuit which is named as IC 741. So hope the knowledge of the operation amplifier as inverting, non-inverting and as a adder is now clear from this particular video, and I hope you have enjoyed this video.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.